Awesome. Hi, everyone. My name is Shima Shams. I'm a project scientist at Research Application Lab and ACOM at NSF NCAR, and I have the pleasure of being the chair for the upcoming 2 plenary sessions. Just some housekeeping. We will have the same structure as the previous talks, 20 minutes for each of our speakers, and then at the end we have everyone to come in, respond to questions. For Marlene, if you feel like it's easier, we can have your questions right after your talk because she's in Europe and the time difference, we can acknowledge that it would be a lot of, it's quite late over there. So without further ado, I introduce Marlene Dekker from the Leiden University in Netherlands to talk over some of the social science perspective in this work.
Thank you very much. Can you all hear me?
Yes, we can hear you.
Okay. And could I pull up my slides because I get a message that I cannot share my screen?
Yep, you can go ahead.
All right. Thank you very much. There we are. Oh. Can you see my slides?
Yes.
Excellent. Thank you very much. Good morning, all of you down there in Boulder, and good evening for all of us on this part of the world. I would like to start by saying thank you very much for Weng Fu and Peter Nell and the organizing team, of course, for the invite, but also for putting together such a great program. It is unfortunate that I cannot join you in Boulder, but I'm very happy to be with you part of the time from the Netherlands. My name is Marlene Dekker. I'm a professor of inclusive development in Africa and the scientific director of the African Study Center in the Netherlands, Leiden University. The African Study Center is actually the only institution in the Netherlands that is entirely devoted to the study of Africa or the study with Africa, if you like. Mostly from a social science and humanities perspective. And I will indeed present this social science perspective to air quality measurement and climate issues in Africa. Mostly based on work that I'm doing together with Agnieszka Kazimierczuk, who's a guest researcher at the African Study Center, and work that has very much been inspired and informed by exchanges with Peter Nell, with colleagues, with her colleagues at KNMI in the Netherlands and elsewhere in the world, and some of you are actually in the room in Boulder. And why I think it's important to bring this social science perspective, it was referred to already earlier this morning, is that many of the global challenges that we are facing today require interdisciplinary work to be addressed. It's climate change, it's about inequality. Air quality is one element, but I think, as Weng Fu rightly pointed out, more broadly applicable to many environmental issues. What I want to do is to very briefly provide you a little bit of introduction and background. I think Peter Nell already mentioned it in her opening address, that my inaugural lecture back in 2017 sparked an idea in her head, but I think equally important, or perhaps even more important, is the launch of the TROP-OMI measurement instrument in that same year. And since then, indeed, we have been discussing about ways to bridge those fields, those academic fields of our interest. In the Lawrence workshop that Peter now referred to, and I will briefly talk about that later on, but also in the workshop on a pilot design for air quality in Africa in Kigali, Rwanda last year, that was organized by Professor Solomon and some of his team who are with you today. Both workshops really emphasize this inter or multidisciplinarity, and being a social scientist trained in geography and economics, I would indeed like to share some of the social science questions, but also some of the current initiatives that I'm working on, or that we are working on. Before I continue, I would like to make one point, and that is that very often in discussions like this, we discuss Africa as a continent. And I will also do so in this presentation. But I think it's important to stress that the continent, in fact, has 54 countries, and they can be quite different from one another. Where, for example, some countries trust their national data and their national scientists much more than external scientists, while in one of the interventions before, we heard the exact opposite. And I think it's important to acknowledge this diversity in the discussion. Then, again, I prepared a slide on air quality or air pollution in Africa, and many of the issues we have or have been raised already, so we'll go over this very quickly. There are persistent data gaps, both on the status and spatial distribution, as well as the impact of air pollution in Africa. But what is quite clear is that because of a lack of access to healthcare, low nutrition, and the high prevalence of infectious diseases, the African population is generally more susceptible to the impact of environmental pollutants and air pollution in particular. For that reason, air pollution is estimated to be the second largest cause of death on the continent, and the economic costs are quite high, an alarming 6.5% of Africa's GDP. Of course, we also already talked about the projected increase in population in Africa with the related economic and industrial development, urbanization, and exposure to air pollution is expected to grow exponentially in the coming decades. This narrative was in fact the background of the Lawrence workshop that Peter Nell introduced earlier this morning. And I just wanted to, like she said, it was much smaller than the meeting that you have today. But in the meeting, we had a very interesting mix of academia, practice, and policy, mostly female participants, some of them mid-career, but also senior and early career researchers. And like the workshop today, a very interesting spread from participants around the world. And we kickstarted the discussion in that workshop with specific social science angles in this predominantly natural science field. And I will try to share 4 main strands of questions with you today. And those are the contextual and behavioral determinants of air pollution or air quality and inclusive development, related to issues of environmental justice, knowledge production on air quality in Africa and inclusive academic communities, and the use of satellite data or air quality measurements in policy and public debates. For the first set of questions, social scientists are very engaged in these more contextual and behavioral determinants of air pollution or air quality. And earlier this morning, also an intervention was made on understanding reasons, for example, behind biomass burning. In the specific context of Africa, indeed, biomass burning, the existence of large landfills, but also the current vehicle fleet and domestic fuel use are often referred to as reasons for or contributors to the air quality on the continent. And I would like to think along a couple of the examples. So for example, when it comes to biomass burning, what I'm showing you here on the slide is a field of sugarcane that is being burned before it is harvested. And this is in Sudan. The reason why these fields of sugarcane are burned is because it's much easier to harvest the cane when the leaves are not there anymore. As well, the fire chases away, for example, snakes that are in the fields and may pose an issue when harvesting is done. But also the sugar content of the cane is better maintained when the cane is harvested quickly, and it is easier to harvest quickly when there are less leaves on the cane. So I think this very nicely illustrates why particular, let's say, economic or behavioral patterns can be observed and explain why, for example, burning of sugarcane fields is very common. Similarly, fields are burned after the harvest to get rid of crop residues. And of course, as was also alluded to, there are a number of wildfires are quite common. Landfills, because waste collection is limited on the continent, landfills are also quite common and a source of pollutant. Vehicle fleets are generally old, again polluting, and this goes for trucks as well as cars, but also motorcycles, also adding a lot to the air quality, or actually the bad air quality. And another example is the domestic fuel use, especially the fuel that is used for cooking. And this, I think, this environment, not environmental in the sense of, these contextual factors very much determine how air quality can be understood in Africa. It may, in fact, also raise questions on what this means for the modeling of the emission data, for example. And I think it raises the question on what can be done about it. This is also a question that came up earlier, and I think it's important to reflect a bit on that, because on the one hand, it may seem simple that if you change the type of domestic fuel that is being used, great strides can be made. But we have to realize that very often, or there has been quite a lot of experiences with these type of policy interventions already. And here I'm showing a systematic review of 75 studies into domestic cooking. And this study distinguishes 37 factors that influence the uptake of improved solid fuel stoves. And these improved solid fuel stoves are much cleaner than the current domestic fuel that is often used. And of course, I will not go into all the details of all the factors, but I think the point I would like to make is that indeed, as was introduced earlier in the discussion, there are many factors that one has to take into account when thinking about issues or contributors to air quality and changing, for example, the use of fuel. A second set of questions that social scientists are interested in is about the relation between air quality and inclusive development. And this very much also relates to issues of environmental justice that were already introduced in the morning session. Not only environmental justice when it comes to the global or the regional scale, but also environmental justice at a national or local scale, referring to the impact of air pollution, for example, on different population groups. And then the key question is which section of the population are most at risk? And like in other areas of the world, very often what you see is that there is a concentration of air pollution in certain residential areas, in certain economic sectors. It may affect learning outcomes of pupils in school. And we see, for example, that very often, especially in the domestic context, that women are much more exposed compared to men. When it comes to the economic activities, I would like to also draw your attention to some of the work that has been done with tropomi data on solar-induced fluorescence, showing that how air pollution also limits crop productivity. And similarly, of course, different population groups, different occupational groups are more exposed to polluted air than others. And I think this issue of inequality or environmental injustice is a key debate. It's a key debate. It's a key trade-off between, let's say, improving lives, better health, or livelihoods. And that trade-off or that tension is an important field of study in social sciences as well. And it's not only about looking at how, for example, different groups are affected differently, but also how people or different people perceive and respond to the risk of being exposed to air pollution. And also what can be done to reduce this exposure. The third point that social scientists are quite keen to study is what we refer to as the knowledge production on air quality in Africa and how to build inclusive academic communities. I'm very happy that already in this morning's discussion, this point was actually put at center stage. And here I'm projecting on the slides two figures from work by Overland and colleagues that indeed show the difference in funding for climate research between Africa and the world, and also the top 10 locations of receiving funding for climate research on Africa. And it's quite clear, as was brought forward already this morning, that funding to African countries or for African scientists is limited. And I think it's important to also think through a little bit what this means, because it also means that when funding is more limited, it also means less, it usually means less African researchers are involved. And also African researchers are less visible, for example, in publication outlets. When thinking through, I think what is important to also highlight is, and it was highlighted, I'm very happy that it was highlighted before already, is this African involvement. And not only because of the relevant and contextual knowledge that is urgently needed, but more so in its own right, in a belief that it's important that African scientists will drive and contribute to this agenda and have agency in defining the agenda themselves. It's about how to integrate, let's say, the internal and external knowledge, or these different knowledges, and for Western scientists to also be humble about what we can contribute, and be careful in listening what is put on the table. And one issue that we noticed back then in the Lawrence workshop in Leiden is that very often we assume that data that is publicly available, that is open access available, is in fact easily available and usable for scientists in Africa, for example. But we realized in discussions with some of our African colleagues that issues of electricity supply, issues of computing power, issues of having to buy data bundles or having to buy data bundles to be able to access the data can actually put up quite a number of barriers to be able to use the data that is available.
Marlon, just a reminder of the last minute.
Yeah, thank you very much. The fifth point that I wanted to discuss is the use of air quality measurements in policy and public debate. Of course, we talked about it already in terms of the data gaps. And I think it's important to also emphasize how increasingly citizen science actually plays a role there, not only in making data available, but also as a tool and collecting the data as a tool to start a discussion on awareness when it comes to creating awareness when it comes to air quality. Secondly, the point that was also brought forward is how one can use either data or participatory processes to co-create understandings with local communities, with local policy stakeholders as part of this transdisciplinary approach or conversion science. I have one very quick slide on the current initiatives that we're working on, but that one is also included in the slide deck that has been collected for all participants. So I wanted to end with this slide, which makes reference to a source of information, the Padlet that collects all the information that we gathered in the Lawrence workshop 2 years ago. So that's still accessible. On the right-hand side, you see the white paper or the working paper that Peter Nell referred to earlier in this morning's presentation. And I've also included my email address in case of any questions or suggestions, because I was thinking I wouldn't be able to join the discussion or the Q&A session. Thank you very much.
Thank you so much. We have time to have a quick question if there is anything that someone wants to discuss in the room or in the chat.
Yeah, thanks a lot for that. So from a practical perspective, we have been doing some work in Ghana, which is air quality monitoring at secondary schools. And we got some funding from Professor Dan, the NSF-led group CAMSNet from Columbia University. And what we've realized is this, that we don't just put a census at the secondary schools, but we also, use the data, improve that because it's from a local sensor. And we have collaborated with local MPs, members of parliament, and so shifting the change. And so you go to one of the secondary schools in Accra, for example, what is done is that they've changed the cooking from using charcoal and solid fuel to an improved one, a cook stove. But the challenge again is that, as is mentioned, behavioral change. So they're used to the old way of doing the cooking. And so it is very difficult for them to even switch. They use the old. And so you don't get to see how that is going to improve air quality locally, especially within the kitchen area where it's mostly the women that are exposed. Then the other part is, as early career scientists, it is very difficult to actually get the funding to do the meaningful work. Even though what you're doing is meaningful, it is very difficult for people to trust what you're doing and also give you the funding to push that. And so we haven't had a lot of money to do anything much apart from the little that we've had, and everything being done is from our pocket, right? But we have been shifting the paradigm in Ghana. Example of that is that We also collaborate with the members of parliament, and there's a bill that is proposed now on the right to clean air, but getting a support even to push that further is another thing. And so how do we, balance all of this? Thank you.
Thank you so much. Marlene, do you have any comments to add to it?
Yeah, thank you very much. Thank you very much for that, for sharing those examples, because I think it's really important and also exciting that you've actually been able to move the needle already quite a bit. And I realize it's taking a lot of effort, and usually this type of engagement may not necessarily be covered in a research grant. It would be interesting to reflect a little bit on that also in the context of the Belmont Forum presentation, how this type of work increasingly is also included as part of the research budget. I know that in the Netherlands, the Dutch Science Foundation is increasingly demanding actually of research consortia that they spend a minimum of the budget on these type of engagement activities. So I think moving the needle on research funding and the type of activities that will be covered under research funding is an important element there. And I very much recognize what you say about how you can make small changes in a very, let's say, in one particular area, the secondary school that you are referring to, but it may take a long time before, let's say, the spillover effect or the role model effect of those changes are becoming visible. That's an issue with policy change. It's change that requires patience. It's change that requires long-term vision. But I think it's really encouraging to hear how you have been able to start as a role model in the Ghanaian context.
Thank you so much. This was absolutely great to hear your feedback. I hope we can have more of this discussion tomorrow in breakout sessions, and feel free to email workshop organizers so we can have all of these reflected in the white paper that be finalized at the end. Okay, with that said, I invite Forrest Lacey from ACOM RAL to come and talk about air quality health and different efforts that has been happened.
Good morning, everyone. I'm going to talk to you about not just my research, but also highlight a lot of the research that's being done targeting air quality in Africa by a number of people that both are able to make this workshop in person, but also those that are either remote or traveling during the workshop. So I will try my best to represent these projects. But if you have any specific questions, I would recommend reaching out to the researchers themselves, or I can contact you with them. Next slide. So this first project is one that I'm involved in as a co-investigator, where Rajesh Kumar at UCAR is the PI. So co-Is Shima and myself are involved in enhancing air quality decision-making in East and Southern Africa. This is part of the NASA Severe program that was mentioned by Kenneth and USAID. And what we're doing here is we're trying to build an environment where countries in the East and Southern Africa region of Severe are able to run their own air quality forecasts based on their own needs and wants within that forecasting system. So in order to do this correctly, we both have to involve local researchers. So we have a number of researchers at each of these 7 countries that we're highlighting here on the survey, where we're getting input from them about what are challenges locally. And so to do this, we've developed this survey, which I'm showing some results from here. The QR code also takes you to the survey if you would like to fill this out and have provide additional information to us. But we're looking at information about kind of the organizational background of the person taking the survey. Who are they currently working with? What is the capacity for air quality? And what are the challenges within your region for air quality? And then finally, what level of education and training would you like to see? So we've sent the survey out, and the first set of results are in. And one of the main takeaways from this is that most of these people have the mandate from their government to provide air quality data, but they don't have the capacity to do it within their mandate. So this highlights the importance of this work. And so we've developed a WRF-Chem data simulation framework that we're using for air quality forecasting in other regions, mainly the United States and in India. And this takes satellite data and assimilates it within the system to create a 48-hour air quality forecast. And the plan for this throughout the life of the project is that we'll develop and run a 15-kilometer domain shown here that covers our member countries in East and Southern Africa. And this allows for a higher resolution inner domain down to 3 kilometers if needed, that stakeholders can run on their own using data from the 15-kilometer results. And so this allows for simulations of interest. So let's say you're interested in isolating sources such as transportation and biomass burning. You can run a simulation that isolates tracers from those specific pollution sources, whereas some of the coastal countries may be more interested in emissions from shipping and things like that. So it's each of these countries have different needs, and this allows them to work within that framework. Next slide. The next one that I want to go into is some of the modeling efforts that NCAR is doing within Africa. The first one is a paper that was published a couple years ago where we used a WRF-Chem to isolate using CO tag tracers to isolate both source-specific contributions to air quality and region-specific contributions to air quality. So the plots being shown here, kind of B shows the different regions we isolated, and then the different sources that we isolated are being shown down in the bottom. So we isolated either transport from outside of the domain, anthropogenic sources, biomass burning sources. And so the plots at the bottom are showing, okay, in East Africa, how much of the anthropogenic pollution is related to localized sources versus how much is transported in. And you can see that in most cases, almost up to 80% of the anthropogenic related CO is from local sources. But if we look at something like biomass burning that has both a seasonal cycle and a lot of regional transport, maybe only 20 to 30% of the CO in that region is from local sources. So it's really important to understand where is our poor air quality coming from, and this study was an attempt to highlight that. And then building on this, this is work that Wenfu's done. She's developed a Musica grid for Africa. Musica is kind of a next generational model or iteration of the community Earth system model, where it allows for regional refinement in a specific position. And here, this is the grid over Africa. So it's going down to around 10 kilometer. And this grid should be available for public use. If you would like to try using it, talk to Wenfu. Other efforts that at NCAR, specifically being done by Rajesh and Wenfu, are on the integrated assessment of air pollution and climate change for sustainable development in Africa. And so NCAR scientists have contributed to chapter 2 of this, which is looking at the trajectory of sustainable development and air pollution under kind of current policy trajectories. And so this report was published as part of a CCAC coalition, and you can find it at the link here. And it has a lot of good information for African researchers as well. And then the final NCAR-led or NCAR-involved project is on the project Air Pollution Mitigation Actions for Megacities in Africa. And so what we're targeting is different megacities, which we've seen are growing in population and will continue to grow throughout the 21st century, and how air pollution evolves in those cities, and what can we do to reduce the burden of disease associated with air pollution. So here, Rajesh Kumar collaborated on modeling efforts in that focus on part of this report, and this has a large influence from both researchers in France and the Ivory Coast. So you can see the list of institutions involved here. NCAR provided some of the modeling data that's used for this and will continue to be used throughout the life of this project. And now we're going to move on to the external projects. So these are people that are involved in the UCAR Africa Initiative and work that they're doing. So I'll try and highlight it to the best of my ability. But if you have specific questions, like I said, please reach out to them. So Ave at the University of Arizona has been using satellite data in conjunction with bottom-up inventory. So bottom-up inventories are inventories that are created through emissions factors and local knowledge, and comparing trends in various regions about, okay, what do we see in the satellite data for growth of different pollutants, and what do we see in the bottom-up emissions inventories for changes in different pollutants as well. And here we're seeing a discrepancy between the top-down or satellite-based observations and what's created through kind of emissions factor-based inventories. And so this really highlights the need for localized observations to find out what's really going on in some of these regions. And so Ave's highlighted that here. In addition to this, he's also doing some work looking at the impact of ozone on agricultural production in arid environments, so such as Morocco, and then deriving environmental vulnerability indices for developing countries. And then finally, he's also involved in a number of different projects that are constraining emissions using satellite data, so specifically emissions of gaseous pollutants. Next is Solomon's work, and he provided this slide where he's basically his group is using a lot of chemical composition data to better derive some of these emissions. So these emissions factors that he's developing are what go into those bottom-up emissions inventories. And so here he's looking at, okay, what if we have Africa-specific biomass burning pollutants in a chamber? What happens? Do we get ozone formation? Do we get PM 2.5 formation? And this is really important because we need to have understanding of biomass burning emissions will be very different when measured in the US versus what's measured in Africa due to different plant functional types, different burning conditions. All of that goes into what is the air quality impacts. And this is something that's not really captured in the models. So this is really valuable work. I think that Solomon and his group have a poster on this as well. So feel free to talk to him throughout this workshop. Next is an extension of the work that Marlene was talking about, where Dr. Agnieszka Kazimierczuk is looking at integrated interdisciplinary works focusing on air pollution in Africa. And specifically, they're looking at some of the links between indoor air quality and ventilation practices and how they differ between Europe and Africa. Because as we know, there's much different building structures, there's much different pollutant types. And so having that understanding will let us better understand how we can apply some of these health metrics that are derived from the developing world. How do we need to change them in order to apply them in Africa effectively? So if you have a different ventilation rate, you may have buildup of polluted air within the home, and that would lead to an underestimation of what a person's exposure is. So this is really valuable work where they're combining kind of health, social domains, economic, and then also structural scientists as well. And so the partners are listed here on the left side. And then the other project that she highlighted is Respira, which is a transdisciplinary action research to tackle air pollution and chronic respiratory diseases in Africa. This is a really important project because they're training 15 PhDs throughout Africa in developing links between chronic respiratory diseases and air pollution. The next one is work that Eloise Murray's group is doing. She's been doing work in Africa for many, many years. And this specific paper that is in review right now is using satellite data, specifically Tropomi NO2, and finding hotspots of NO2 pollution. And so here she's been able to identify 28 urban and industrial hotspots. So these could be anything like large-scale energy production facilities, to cities, to mining operations, things like that. And looking at, okay, what are the emissions from these being constrained by satellite observations? And so this is, like I said, this is just one of her projects. She has a number of other ones that are being done in Africa, but this shows an application of satellite data specific to Africa, Tropomi, we have observations over Africa, and how that can be used to build our understanding of air quality within the continent. Next is specifically some work from KNMI, which is in the Netherlands, where Dr. Deborah Steyn-Veers is looking at how we can get Tropomi data and get that into the hands of stakeholders within Africa. So she's doing a lot of analysis of Tropomi data, creating data sets and applying it to specific cases. But she's also developing this with the understanding that this data really needs to be in the hands of African researchers. So she's developing a couple different portals and integrating it with the Google Earth engine so that this is something that you would be able to grab this data, look at it for your locality. And then she's also developing some specific use cases with African collaborators. So specifically AirQO, which is an African company based in Uganda that's looking at how to develop clean air in African cities. And so they have a number of low-cost sensor observations throughout a number of different cities in Africa. And by using Tropomi data, they can better understand if their low-cost sensor networks are accurately representing air quality within Africa. Next, we have the GOSAT GW mission, which is from the National Institute for Environmental Studies in Japan. And on this platform, they have, which is being launched between 2024 and 2025, they have the Tanso 3 instrument, which is a spectrometer that will be looking at emissions mapping, specifically of gaseous pollutants such as CO, methane, and NO2. And this will provide high resolution data, well, relatively high resolution data, around 10-kilometer data, at a 3-day cycle for Africa. This also has the capability to provide higher resolution data on a kind of a targeted approach. So there may be opportunities once this is launched to submit a proposal to NIES and to try and get high resolution satellite data for a specific project or a specific city or region in Africa. So this is something to keep an eye out for after this launches within the next 2 years. And then final slide is some of Dan Westervelt's work. I would recommend you talk with him during this session. Like Eloise, he's been involved in Africa air quality research for a long, long time. Here he's showing his aerosol group, specifically the ones working on African air quality and climate. And he has a number of different projects. I don't think I have the time to go through all of them, but some of them are developing city-based metrics, combining observations with modeling data to understand what are the sources of air pollution or what is the air pollution within a specific city or a specific region. This nice map that he provided down in the bottom shows all of the cities where he has current active research projects. And he also is involved in kind of the planning for the field campaign in Eastern Africa, where we're working to observe air pollution that hopefully we get funding for and we'll launch within a couple years. And I think that's the last one I have, and I'll take any questions at the end.
Excellent. Thank you so much, Forrest. So now I invite Isla Simpson from CGD to walk over some of the climate projects.
Hey, thanks. So it's a pleasure to be here today and to go over some of the work that's going on in climate in relation to Africa. So I'm Isla Simpson from CGD and NCAR, and I'm kind of co-leading this climate aspect with Akintumidi Akinsanola from the University of Illinois. So I didn't put our names on the slides because this is really contributions from many individuals, mostly from within NCAR and UCAR. So I've kind of divided the research into 5 categories, but there's definitely overlaps here. Some of these projects really fit into multiple categories. So I'm going to start off with the model development aspects, and in particular, some high resolution work that's going on in the realm of modeling. So NCAR develops a number of models, but we have kind of 2 primary global modeling systems that are used for different applications. We have the community Earth system model, which is developed in CGD. And so this is really emphasizes complexity. So this is fully coupled ocean, atmosphere, land, sea ice, land ice model. There's biogeochemistry options, and there's chemistry options. And this is used for climate projections and also shorter term predictions, so seasonal to decadal predictions. And so CSM3 is under development. This is what the components of that model look like. And we also produce a lot of data sets with this model, like large ensembles of climate projections that can be downloaded by anyone and used. And then there's also the model for prediction across scales, which is developed primarily in M3. This is an atmospheric model. It's coupled to the NOAA land surface scheme. And this really emphasizes high resolution applications. So it has this mesh, which you can either run kind of with global uniform high resolution, or you can do these kind of regional refinement things where you can have regionally high resolution over local areas, and I'll show some examples of this. So MPAS is especially suited for high resolution applications, and CSM is suited more for long-term climate projections where complexity is key. So starting off with kind of some of the applications of these modeling systems that will be either directly or indirectly relevant to Africa. This is a slide from Falco Ute from M3, and he's running global 3.75 kilometer simulations with MPAS. And so when you get to those scales, you can bypass convection schemes, which is a kind of a big parameterized uncertainty in our models, and explicitly start to represent the convection. And so he's running these year-long simulation for the Diamond Phase 3 project, and he's happy to make the data available to anyone who's interested. So this would give data over Africa and globally down to 3.75 kilometer resolution over a year-long period. There's also efforts going on in high resolution, not quite as high as what I just showed, but higher than our typical climate projections within CESM. And in particular, there's this new group, this Mesoamerica Affinity Group, which is a group of researchers from different labs that are interested in the Mesoamerica region and the Caribbean region. So that's their focus. But they are going to be running these kind of high resolution, regionally refined simulations down to 25 kilometers in this domain. And this domain extends over North Africa because that is an important region for influencing hurricanes and things in the Caribbean, which is their focus. But so they're planning to run these 30-year-long AMIP simulations with regional refinement down to 25 kilometers and 12 kilometers, which will be a new data set that people can use to look at North Africa as well as the Caribbean. There's also other high resolution regionally refined simulations going on in CSM. This is a slide from Brian Medeiros, and he's been running CSM with regional refinement down to 15 kilometers in the tropics. So that covers some portion of Africa. He's run these 7-year simulations, so they're pretty short, but this is kind of the first time to simulate the whole tropics with CSM with this kind of resolution, where you can look at things like how are tropical waves represented, or extremes like tropical cyclones and atmospheric rivers. And an example is shown down here of how the difference this makes to the precipitation distribution. So you're seeing that in the low-res model in the gray, you just don't capture these high precipitation rates over West Africa. But when you get to the red, the 15-kilometer simulation, you do much better compared to the observations, which are shown here in blue. There's also work going on to look at resolution and biogeochemistry in the ocean. So this is a slide contributed from primarily the oceanography section within CGD. And they have an interest in these upwelling regions off the coast of West Africa and the Benguela Current region. And they're running these offline forced ocean simulations to try and reproduce real world variability, and then coupling that with kind of state-of-the-art biogeochemistry representation. So there's a biogeochemistry module within CSM, and then this new fish model, FEISTI, which is kind of trying to represent the interactions between the kind of physical aspects of the ocean, the biogeochemistry, and then ultimately the fish. So this might be useful for looking at things like how are fisheries responding in these regions to climate variability and change. And they're running simulations with high resolution, like you see on the left here, and low resolution, like you see on the right, to investigate this. So now I'll move on to some initialized prediction efforts. And these are going on with both MPAS and CESM. So starting off with MPAS, this is a slide from Robert Nystrom at MQ. And he's using MPAS to look at the predictability of tropical cyclones, or the large-scale environments in which tropical cyclones form. So he's using MPAS at a 15-kilometer resolution, which does pretty well at getting your tropical cyclone climatologies represented. And he's looking at predictability in kind of a perfect model sense. And so, of course, Africa is important for determining the behavior of tropical cyclones in the Atlantic. And here he's showing the predictability of this large-scale quantity, which is relevant for tropical cyclones, as a function of lead time, and showing that there is potential for predictability in this model beyond a 2-week lead time. In CESM, there's more efforts on the longer timescale prediction, so seasonal to decadal prediction. And in particular, CSM has produced this data set that we call SMILE, which is the seasonal to multi-year large ensemble. And so this is a suite of initialized predictions that go from 1979 to 2019, with 20 members for each initialization date and 4 initialization dates per year. And one of these is currently being extended out to decadal timescales. So these data are freely available to anyone who wants to use them. And what I'm showing you here are some new results from Steve Yeager on the decadal predictions. And in comparing the skill of CSM2, which is the latest model, with CSM1, which is the previous generation. And interestingly, there's a lot of skill over the kind of Sahel region. And that's, I think, primarily because there's skill in predicting how the North Atlantic Ocean evolves on these timescales. I should have mentioned, this is lead years 6 to 10. So we're talking about years ahead of time, and this is precipitation. And what you see is that CSM2 has improved skill here over West Africa compared to CSM1, and he's investigating the origins of that. And just out of interest here, this is the predictions of CSM for precipitation for the average of years 2029 to 2033. So in these regions where we have some skill, you can kind of maybe trust this, and it suggests that this period is going to be wetter than average. Then there's kind of a lot of researchers going on to basically understand climate variability and change, with some focus on Africa. So the first of these here, this is a study by John Fazzulo, and he's looking at the impact of volcanic eruptions on the climate of Africa, and in particular on Mount Pinatubo. So in 1991 and 1992, there was a pretty extreme drought in southern Africa, as documented here in the New York Times. And then what they've done is to run CESM with and without Mount Pinatubo in the simulation. And what you see here in this figure is the difference in precipitation for November of 1991 between the simulation with and without Pinatubo. And what they find is that over this region of Southern Africa, the influence of Mount Pinatubo is acting to give you precipitation anomalies with a magnitude and seasonality that kind of resembles what was seen in observations. This is a slide from Kelly, she's using MPAS to look at the effects of global warming over Africa at a kind of an unprecedented resolution. So this is using, again, MPAS, but now with regional refinement down to 3 kilometers where you can permit convection and you don't have to parameterize it. And using this pseudo-global warming approach where you kind of warm the sea surface temperatures to mimic the effects of global warming and investigate things like how is precipitation expected to change, how is water vapor expected to change, and then how is the monsoon inflows and things expected to change at this very high resolution. There's also work going on to understand projections of temperature. This is from an ASP postdoc, Osamu Miyawaki, and he's looking at the warming of hot days compared to the average. And it turns out that Africa is a place where there's a lot of amplified warming of the hot days compared to the average, like you see here, particularly over the Sahel region and parts of Southern Africa. And he's been trying to understand why we get these projections. This is kind of the end of this century compared to now in global climate simulations. And it turns out to be a bit of a complicated story, but there's connections to the hydroclimate and how the soil moisture changes over the Sahel, and also kind of the different regimes, hydroclimatic regimes that occur during average days compared to the most extreme hot days. There's also efforts going on to look at geoengineering and how that might impact on Africa. This is a slide from Simone Tilmes, and she has been running global simulations with stratospheric aerosol injection, and those are all done at relatively coarse resolution, 100-kilometer simulations typically with CESM. But now what she's going to do is do more regional refinement where the circulation outside of the refined region is nudged to that of the original experiments, and stratospheric aerosol engineering is imposed, and then she can look at how does that impact on things at this finer resolution over Africa, which would allow comparison with the low res to see what are we missing when we do these global simulations, and also comparison with other statistical downscaling techniques as well. This is a slide from Kwesi, who's here, and he has a poster on this afternoon, also looking at stratospheric aerosol injections and the impacts on the Harmattan season, which is this dry, dusty season over West Africa. And what you're seeing here is changes in the wind speed, which obviously has impacts for the dust. Under this, on the top is just under kind of regular global warming, and on the bottom is what you get if you add stratospheric aerosol geoengineering. And so it's not a straightforward picture, and Kwesi can talk about it more, but basically what you see is that in December, geoengineering kind of reduces your increases in wind speed, but it has relatively less effect in these other months. This is another slide from Kwesi, he's also looking at changes in these extreme indices in climate change simulations, and I think the plan is to extend this to geoengineering simulations as well. So looking at things like on the top here is the change in the number of tropical nights. So these are nights where the minimum temperature is above 20 degrees Celsius. This is under a particular relatively low emission scenario, and what you see is, of course, an increase in the number of tropical nights. And then on the bottom is the change in the number of heavy rain days. So you get spatially varying responses in these simulations. There's also efforts underway from a group in CGD to develop simulations for the next CMIP 7. They're looking at what are the impacts of Sahel greening, and thinking of like there's kind of evidence that the Sahel is greened, and then this would continue. You can see here, this is a figure from the IPCC, which is showing kind of reductions in drought over the Sahel as you go into the future. And so they're planning some idealized experiments under a kind of global warming situation. What are the impacts of having greening of the Sahel, both locally and then globally as well? This is a slide from Ben, who I think also has a poster today. Of course, knowing what carbon is going to do is extremely important for the climate system, and that relies on having an understanding of the sources and sinks of carbon from the land and the ocean. And so he's using observations to look at this. And this is showing the kind of net fluxes of carbon over Africa. And I think the point here is that the satellite observations suggest that a big source for Africa, but they have kind of other more constrained approaches, which suggest that there's actually less of a source. So there's some uncertainty there, and Ben can talk to you more about that at his poster. We have a couple of projects on impacts and adaptation that I'm going to quickly run through. So Jonathan Vai and Ral, he's developed this hurricane risk calculator where they use kind of weather forecasts, I believe, and then downscale them with this flow-dependent wind hazard model to come up with predictions for the coming days of what is your risk to high wind speeds. And so they have this nice website where you can go and get the information, and you can see it either in kind of text form or in graphical form. And the example here is for the risks of wind speed at a particular time in Mozambique. And then through the UCAR Innovators Program, which is a program that aims to connect NCAR scientists with social scientists, there's a project going on to look at the impacts of agroforestry, and the focus is on two locations. One is San Diego State County, but the other is Henan District in Tanzania. And so the idea here is to characterize the climate of these two regions and talk to farmers and see what information do they actually use, and then characterize the extent to which agroforestry is being used and evaluate its benefits, both biophysical and socioeconomic. And so this is Amy Quant at San Diego State University that's leading this. So yeah, that's mostly NCAR, UCAR efforts that I've talked about. I just want to finish up with a couple of slides on kind of broader collaborative efforts in the climate. And so this there's this CLIVAR GWEX monsoons panel with the regional working group on African monsoons, and that's being led by my co-lead of this presentation, Akintumide Akinsanola, who can talk to you about this more. But this is basically a working group that's trying to coordinate research on the African monsoon systems. And it consists of, I think, 22 scientists, some from Africa, some from outside of Africa. And they have a number of activities going on. They're planning sessions at international conferences. They're looking at convection permitting simulations. So maybe there's some opportunities for collaboration with the people I mentioned earlier who are working on that. There's plans to host a workshop, and then they're also leading a review manuscript on this topic.
It's the 1 minute remark.
Okay, thanks. Perfect timing. So to summarize, we have a lot of work going on, either directly or indirectly related to climate in Africa. There's model development efforts. We have large model data sets that are produced and made freely available, and these go from short-term high-resolution simulations to seasonal to decadal predictions, and then longer timescale projections. There's lots of work going on to understand the model behavior and climate variability and change in general. Yeah, so I think that's all I have. Thank you.
Thank you so much. So for next, we have Senling He, who's going to talk about land and water modeling.
Hi everyone. I'm Senling He. I'm one of the co-leads for this land and water working group under the UCAR NCAR Africa Initiative. So I know it's lunchtime. You must be hungry, but please bear with me for another 15 to 20 minutes. So here, let me see if I can. Okay, so similar to the previous two speakers, I'm going to summarize the efforts from the NCAR, UCAR researches first, and then I will also list a few examples from the community efforts, particularly from the university and other agencies. So as we know that the urban and urbanization is a very important topic for Africa studies, and especially when we talk about the extremes and extreme weathers like extreme precipitation. So here I'm showing you the the lower right panel is a news report for these urban flooding issues. So this study is really important for understanding the urban extreme precipitation over the Africa. So here I'm showing you some of the examples for the Lagos, which is one of the most fast-growing mega cities in Africa, led by Dr. Fei Chen, who has recently retired from NCAR but moved to Hong Kong. So he's here. If you have any questions, please feel free to talk to him. So essentially, these studies were trying to understand the mechanisms, particularly the physics behind this triggering and enhancement in the extreme precipitations over urban areas in Lagos. And as one step further to these individual studies, what Fei is doing is that he is currently leading a WCRP, the World Climate Research Program, for the My Climate Risk hub to establish an urban regional hub, including these Lagos, Nigeria efforts. So if we're interested in this effort, please talk to Fei. And I think this would create a lot of opportunities and collaborative projects under this initiative. And in addition to urban, another important issue is about the sandstorm weather and also the interactions between the land and atmosphere. So here I'm showing you the example from Samuel Menandler, who is an ASP postdoc at NCAR, and she's also here. So if you are interested in this lake interactions and weather studies over Africa, please talk to her. So essentially, this study is to understand how this lake and land temperature contrast could facilitate or contribute to a chain of events, including, for example, the lake evaporation, wind pattern changes, moisture flux convergence, as well as the precipitation. So this work really highlighted the role of the African Great Lakes in modulating the environment surrounded by this surrounding this lake at different spatial and temporal scales. So Summer also provided a lot of important or potential promising points for us to further improve the lake representations in the current Earth system models developed at NCAR. For example, the CESM mentioned by Ayla earlier. So if you are interested in these lake representations and also these lake land interactions, please talk to Summer. So related to this study, so another topic is important topic is the water resources in Africa. So here I'm showing you a study from the Wolf Hydro Group at NCAR RAW Research Applications Lab by using the Wolf Hydro modeling ecosystems, which is a very powerful community hydrological model system. So by using this to do the stream flow prediction researches and also diagnose the climate change impact on water resources over Africa. So as you can see, this community model is actually used by a lot of different groups and people all around the world. So as you can see on the right panel, I'm showing you the coverage, the user spatial coverage for these Wolf Hydro models. And also you can see that some of them are from Africa, although it's still limited right now. But I think as we become know more about this, it's really a powerful tool to be applied to Africa studies, especially for the water resources. So in addition to this, really the fundamental scientific research is using these powerful tools. Another important thing to do is to help the local agencies to deliver the accurate information to the users and the public. So here I'm showing you an example from Jennifer Bonner at NCAR to design these GIS based systems to deliver the real-time information from over the Ethiopia and also East Africa for the precipitation and also the stream flow, as well as some other water resource relevant quantities. So if you are interested in this, please either look at this website at the lower right corner of this slide, or you can directly email Jennifer to see how this platform can be further applied or extended through some collaborations in the areas you are interested. Okay. So another study related to the stream flow prediction or water resources is from Naoki Mizukami from RAW in collaboration with people from the International Water Management Institute. So what they did is that essentially to apply this Mizo River channel model developed at NCAR here, and then apply that to the entire Africa river channels and water basins. So as you can see in the lower bottom, they have a lot of very detailed river channel informations, and then in the model, and then they trying to predict this stream flow monthly. And in the right, you can see on the right, you can see these animations for the monthly or seasonality of these stream flow predictions over the entire Africa. So this provides a really large data set, but very useful information. So if you are interested, please contact Naoki. So another potential exploratory collaborations from between NCAR and WMO expert team is from the Dr. Andy Wood from NCAR CGD lab. So essentially this issue arises from the recent interactions between Andy Wood and also the WMO team on the potential the possibilities of operational hydrological prediction services to be created through the WMO project for the West Africa. So similar to the previous map I showed, you can see all these detailed river channel information and also the topography information here over the West Africa. And so they are trying to get this operational system going in this area so that it can benefit the local people or public by delivering more accurate prediction informations. So the last part for the UCAR effort is about this COP28. So as many of you already know, this was a big event a few months ago. So essentially here I'm showing you the amazing NCAR delegation team we sent to Kigali, Rwanda to the COP 28 cities. So here, this is a slide provided by the Kimberly Fearless from NCAR RAW. So essentially what they did is that to try to expose themselves as scientists to really the policy makers and also all those negotiations ongoing to understand how our scientists can support these decision-making activities, and also to trying to get ourselves to be influential in this decision-making by providing more accurate scientific information to the policymakers and government and also all those stakeholders. And one of the things raised by this meeting is that a lot of African countries and all those negotiators have made very strong statements emphasizing the importance of developing these resilient water infrastructures and also the focusing on this water and food security. So this is really an important topic in Africa among all these other issues mentioned by previous speakers. So in the next few slides, I'm going to show you some of the examples from the university and external communities. Some of them are kind of in collaboration with NCAR, but most of them are from our community participants in this UCAR Africa Initiative. So I would mention that this is not an exhaustive list of all the community efforts, but I just want to showcase some of the highlights or highlighted projects here. So the first one is from Professor Rong Fu at UCLA, University of California, Los Angeles. So her team is trying to look at how these complex land-atmosphere interactions can affect these regional mesoscale convective systems, which further are connected to these extreme precipitations and all those water resource issues I mentioned earlier. So as you can see here on the left, these interactions between land and atmosphere system is really complex, and we are still kind of in a limited understanding of this issue. So they try to use this MPAS model, which is the model cross scales, as mentioned by Ayla earlier, to understand this issue over the Africa continent, particularly for these tropical areas. The next one is from Dr. Yan Jiang from University of California, San Diego. So here, basically, she was trying to look at how these tropical Africa regions can kind of the mechanisms contributing to the drought events over these tropical areas. And then what they basically found is that these complicated rainfall, soil moisture, and vegetation interactions over this area really contribute and also prolong this water deficit over the area, which further exacerbate the drought conditions and also affect the food and water securities in this area. And in addition, related to the water issues, so I've mentioned that a lot of focused areas are being to be the urban area. However, actually in Africa, the rural area also is experiencing a lot of water insecurity issues. So here I'm showing you a slide from Professor Dennis Music from CU Boulder, University of Colorado Boulder. So basically his group is looking at two major issues related to this rural water insecurity in Africa. One is the drought issues, and the other one is the flood risks. So as you can see here on the right, these are the maps where all those highlighted drought and flood events or risks are happening in Africa. So their group is trying to connect with the local African scientists and also work on these issues together to try to inform the decision makers and the policy makers to understand this from a more scientific perspective, and also to provide useful information for them to build or enhance the current infrastructures over the rural areas. So the last but not least from the community efforts. So here I'm showing you the farming early warning system network, which we call FuseNet efforts funded by USAID efforts, and also from the NASA Land Information System Group. So this is a slide provided by Kimberly Slinsky from NASA to show that how the NASA group is trying to bring their expertise in the land data assimilation system and also all those used for satellite informations together to enhance our monitoring and also prediction for the drought conditions and flood conditions in this area, especially in over this the entire Africa and also the East and Central Africa. So currently they have this drought and flood operational systems running through this FAIR-DAS FuseNet land data simulation system, so that they can provide the prediction or forecast subseasonal to seasonal capabilities for this area, so that people can take their information to understand the conditions and to help them to better allocate the resources in terms of food and water securities. So with that, I would like to stop here. And if you have any questions, please reach out to individuals here in each slide. But also, you are welcome to send me an email, and I can get you connected with each of these lead developers and also the scientists here. Yeah, thank you.
Thank you so much, Stanley. Just a clarification that the